Let me go ahead and do a little bit of an intro to this video by hand. Sebastian created this fantastic presentation for us. He's a member of our 3D printing community, and of course on the LM Show every Friday at 5 p.m. Pacific on twitch.tv/loyalmoses, we have a 3D printing print race where people print as fast as they can for some secret model that we kind of drop during the show, and everybody competes to win fun prizes. Well, this presentation was created by Sebastian to help members in the community print and, well, slice and print as fast as he does. He is incredibly talented, and we are very thankful for the time and effort, energy that was put into this presentation. I hope you enjoy it.
Hello everyone, I'm Sebastian, and today I'm going to show you how you can maybe win the print race at the LM show. Thanks Mrs. LM and Loyal for inviting me today, and I've prepared this presentation for you. Here is the outline. We're going to look at the printer hardware first, the cooling, the flow, how these can be improved, the clipper for higher acceleration, the calibration of the printer itself, and then also, of course, the slicing, the decision making, how to orient the model and stuff like that, and then how to prepare a slicer profile, which parameters to set, and so on. And then in the last step, I will also give some ideas how you can prepare some things that save a few seconds in the print race. Okay, who is this guide for? This guide is for everyone who wants to join the LM Show print race, which usually happens on Fridays, and you can use any printer you want. This is, however, not suited so much for people who have a really high-end custom printer like a VC bot or something like that, or for other speedboat race like print races which have other limitations. How do you win the print race? Well, it's not about speed so much, it's mostly about cooling, flow, and the slicing, in my opinion, because you can set the layer heights as you want in this case. You can probably win with bed slingers as well, as long as no really high-end machines show up. And the reason for that is that you're printing close to the flow rate limit most of the time. I will show that in the slides later to you. Slicing is also very important because you can shave off so much material there that you're going to have an advantage from that. This is also a point we're going to look at. Okay, let's start with the most important hardware upgrade for your printer if you want to participate in a print race and you don't already have proper cooling on it. This is a really low-hanging fruit. You can improve the layer times, which gains a lot of time when printing fast, and also you get a much nicer print quality on overhangs even if you don't print fast. So if you do a single upgrade, then it would be to replace the 4010 fans which come on many 3D printers, even not so cheap ones, and put 50/50 fans on it and print a proper dual-sided fan duct, and then you should be fine what belongs to the cooling side of the equation. And another really important part, of course, is the flow rate, because usually if you have a properly set up printer and slicer profile, then at the print races you will go close to the maximum flow rate of your hotend and not to the maximum movement speed of your printer. So increasing the flow rate instantly means to print faster. The flow rate is how much material you can extrude in a given time, and to extrude it, of course, you have to melt it first, and there are several things you could do to extrude more. You can bump up the hotend temperature. This has drawbacks, however. You have to consider that you have to cool it down again, then the hotter filament. You could increase the extruder pressure, but then you get die swell because the filament isn't completely molten inside, and it's also not a nice effect. So the only proper way is to increase the melt zone, and here you can see how to do it. For example, either you increase the length of the hot end, or you increase the contact surface by using something like a clone CHT nozzle. These are also inexpensive if you buy the clones from AliExpress or so. And it splits up the filament, has more contact surface, and melts the filament better, and you get more flow out of it, and you don't even have to install a new hot end. Just buy the proper nozzle for your hot end, screw it in, and there is your higher flow. And here I have drawn the graph how it would look like for a normal flow hot end. The demanded flow, the gray line, this would be the ideal situation. And you can see at some point the extruder just skips and you don't get more flow out of it. And even before this happens, you get under extrusion, which is also not nice. But for print resins, we can tolerate a bit of under extrusion. We just want overall okay part, which doesn't have holes and looks okay. But if you really want perfect prints, you do not want to operate in this area where you're under the gray line with your actual extrusion. This is where higher flow hot ends have advantages even for not so high speeds, because they are just more linear in this range here, even if you don't print so fast. So it's not just an upgrade for the print rate, it's a general upgrade for print quality, in my opinion. And yeah, maybe get one of these and see how. If you want even more flow than with upgrade of the nozzle itself, then you can also increase the size of the nozzle, like volcano nozzle. These are also available as CHG nozzles, so you get both. You get the longer melt zone and the splitting of the filament. And if you want even more flow, then you have to probably reprint the tool head and install something like a high flow or a ultra high flow hot end. Of course, the order in the complexity to do the upgrade is this. The nozzle just screws in. Here you have to adjust the end stop and the fan duct, and here you have to reprint the whole tool head. And also the price, I mean, if you look at this, then yeah, these are really cheap. The Amazon ones are a bit more expensive than if you buy them directly from AliExpress, but still affordable. And you can go all the way here to LM's new sponsor and get this beautiful hot end here for a bit higher price, and then you will practically be guaranteed to win every print race, because no one can match your 116 millimeter cubed per second flow rate. Just for comparison, the MK8 hot ends maybe have around 12 to 15 millimeters cube per second. Okay, so you want to buy a new nozzle or you want to buy a new hot end, then important thing to consider is which nozzle diameter do you get it with? Well, many people say 0.8 millimeter or so is better for print races. You can print so much faster with it. Yeah, you can print higher walls with this, but you can also print, or you have to print wider walls with it. So the parameters that you print will take so much flow that you can't go fast enough. And you don't want to print inside of the print. You don't want the wall strings necessarily. Just for the print races, of course, for a helmet also, it's great to have this. But for the print races, you don't necessarily want it, because it takes away the budget of flow and the budget of cooling that you have, and uses it to print inside and not to print to the top. And if you reach the top, you have finished the print and you're done and you maybe win. And if you print to the inside, you just make a more solid part. So for fast print speeds, say 150 millimeters per second or 200 millimeters per second, on average, you can't really extrude so much material that you can afford a 0.6 or even a 0.5 millimeter nozzle if you really go fast. This is something you can calculate, and I have made a small tool for you here. It's also in the presentation, but you can try it here. It's the actual link here. you enter your speed, the layer height, the line width, and the maximum flow rate of your hot end, and it will give you the optimal diameter nozzle and at which speed this will print at. So of course you could say I'm going with a bigger nozzle, but you quickly get in the range where the flow just isn't enough anymore, because this line width here is the problem. You can decrease it maybe to 80% or something of the nozzle diameter, but still you will not get these really big nozzles that are the fastest with your hot end. Even so 20 or 25 millimeter per second squared will give you not more than a 0.5 millimeter nozzle. You have to go really, 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 really high with the flow rate that you get in the ranges where you can justify a 1 millimeter or 0.8 millimeter nozzle. But as you will see, this is about the flow rate that comes with the $1,000 hot end. So this is not something you have on your ordinary printer, even if you upgrade to a better hot end. So keep that in mind and calculate what you could use for your printer. Make sure to use the average speed here. This is not the maximum speed. You also have to consider the small parts. But even with that, you will probably not get recommended something more than a 0.5 millimeter on most printers. Okay, we talked a lot about flow, we talked a lot about cooling, but many people probably think about the actual movement speed when it comes to print fast. Yeah, that's true. The movement speed is also very important, of course, but this is usually not where the printers are limited. Even the bed slingers are not limited in speed, they're limited in acceleration, because the print bed is heavy to move, and heavy to move means you have a big M in this equation, and so you require a lot of force to move the back and forth. And it's the same as with a car. For example, every car can go 100 kilometers per second. It's just the question if it accelerates in 3 seconds or in 10 up to this speed. And to get to print faster, so you have to increase the acceleration. Another limiting factor here is the ringing that you get, and this is actually something you can counter with input shaping, or also called resonance compensation, that comes with Clipper or even your Marlin versions. The Clipper implementation is much better, but you can also use the new Marlin version of it. This will reduce the resonances introduced by the belts, which stretch and give you this ringing on the print, which is not very nice and also can ruin your print. So if you want to go fast, even with a bed slinger, you have to consider Clipper or another type of input shaper, and this can be achieved by multiple ways. For example, you can use an old laptop or something that you already have. Any PC is fine, and combine it with a USB type accelerometer. You can get a Raspberry Pi, Banana Pi, or Orange Pi and combine it with a breakout board accelerometer like this, which is a bit cheaper than the one with USB. Or you can get the all-inclusive solution like the Creality pad here, the Sonic pad, which also comes with the accelerometer already. It doesn't really matter. These are all fast enough to handle your print speeds. These are not limiting you in computing performance. So just get what you are comfortable with, and then you can, even with a bed slinger, print up to 5,000 millimeters squared per second, which is better than what you can print out of the box with it, and probably enough to compete with faster printers, even that have a better motion system. Of course, you can't really compete with a top-of-the-line printer, but it's already a big improvement if you go for Clipper and input shaping. Calibration. This is another step that I entered here before you start to tune your printer on the hardware side, make sure it prints well at normal speed. So don't try to improve before you don't have your printer dialed in at normal speeds. Just something that I also wanted to mention. The material is also important. You can't really use silk PLA or matte PLA or TPU because these just can't be printed so quickly. The silk and matte PLA just don't have the layer adhesion, and they don't stick so well if you print them fast. So you will not have a print that works well. There's an exception for Polyterra, which is matte, but also prints kind of fast. Most standard PLAs are fine. There are some really, fast printing PLAs. You can get some small gains from them, like the Sunlu Meta PLA is not so expensive. You can try it. It's a small improvement, but it doesn't really replace a high flow hotend, so don't think you can just get away with high flow materials here. ABS is actually also fine, but you have to make sure that you really can print this without having a print that then just warps you away and fails. This will also not be that great. So only use ABS if you have the proper print bed, but the really high-speed prints are always done with ABS and not with PLA. If you look at the Benchy speedboat race and so on, PTG would also work, but you have to be careful if you have to remove it quickly. Maybe your bed needs to cool down first, and PTG easily damages some kinds of bed. So don't rush your PTG removal. Maybe stick with PLA then. Slicing. This is the most important part probably, because you can save the most time by just reducing the amount of material that you actually print. So get familiar with your slicer and prepare a good slicing profile, and then when the print starts, or the print race starts, you have to pull all the parts into the slicer and make the decisions, which are first, how do you want to split the model? So look at the print or the part really well, and then decide, do you want to split it? If the model has several parts and you have several printers, always split it. If you have only one printer, it's not an option, but if you have multiple printers, you can also consider to split a single part into multiple parts if you can gain time there, for example, by avoiding support structures, or if it's just really big and you can print faster this way. Then after doing that, we are going to continue with the biggest part on the fastest printer. Then decide on an orientation. The best orientation is one where you avoid overhangs and supports as much as you can, and generally look for printability and also speed by orienting it in a good way. The next decision after doing that is if we can actually print in waste mode or not. If waste mode is not an option, it's not an option for every print, then we are going to decide if it's a good way to print it in pseudo waste mode, how I call it. It's just turning on waste mode, turning it off again, and having one parameter, having zero infill. If it's printable like that, great. If not, we have to consider the amount of infill and external parameters. The prepared slicer profile also has to have a few key functions. It's the layer height for most important parameter, because the faster you want to go upwards, the higher the layer height should be. But a higher layer height also means you can print overhangs not so well. So you have to tune it down later with variable layer height again, maybe. And then, of course, the speed and the acceleration are also something to set. I can't tell you the real parameters here to set, because you have to configure it to what you find out is suitable for your printer. Maybe for a Betzlinger M25K accelerations in 250 millimeters per second with Clipper or something like that on a not too big Betzlinger. And for Boden extruders, reduce the retracts as much as you can. If you can't reduce the retracts, just avoid them and burn away the strings with a lighter after the print finished. The filament parameters are mainly the cooling time or the layer time and the temperature. I would recommend to go about 215 degrees with PLA. The higher you set it there, the faster you can extrude, of course, but you also have to cool it down. And cooling down, is the next big thing. It's the layer time for small parts. A lot of time can be lost here. You have to consider that this is also a parameter that I can tell you what is the best to use, because you have to look at the part again and maybe adjust it, or use time for the layer cooling that you know works well with your printer fan duct and so on. So set this before the printer starts to a value that you know is working. Aim for about a second or so, and not about 10 or 20 seconds. This will not work. The print settings for the general profile are also the parameters, which you should set to 1. If you need more, increase it later. And the extrusion width should be set to something below 110%, because it just wastes material there. Besides the top and the bottom layer, because you have to print the width there anyway, so you can also print a white line. So for everything that is not on the bottom or on the top, don't print too white. And top layers should be really avoided, because I'm going to show you this here. Because top layers on flat surfaces are important, and you need probably more modifiers to adjust the number of top layers here. But these overhang top layers with the zigzag here and these extra parameters that are generated, these are the worst, and they steal so much of your print time that you have to avoid these, and that is why you need to turn down the top layers. And if you need more top layers for a flat surface, add them with a modifier later. I'm going to talk about that next. And the infill should be at its lowest possible. If you need more infill in a part, then also add a modifier. Yeah, modifiers, I just talked about it. These boxes here, these modifier boxes that you can add, you should really use them to increase the strength or so of the part where you need it, and you can print the rest of the part faster. And another thing, of course, is the variable layer height. You can improve the overhangs here, because not everything can be printed with high overhangs and high layer heights. Yeah, and the support structures are also important. If you would need support structures somewhere, of course you don't need it for the Benchy, then you should go and use the paint on supports here, these here, and don't just enable supports for everything. It will generate the giant support structures, which just take so much time to print, and it's something you don't want to do. And now you have finished the slicing maybe, and you want to print, but stop. First we are going to look at the actual preview of the layers, because if the print fails, then it's not enough time to start again. So you have to consider, look at these layers here one by one, and if you see something that will not print, then go back, add a modifier, add a setting somewhere to make sure it will print in the first try. And also make sure you have selected the right slicer profiles, and if you export it, then wait for the export to completely finish. Don't pull out the SD card before it's finished, and use the save extract function for the media on your operating system, so that you make sure it's completely written. Okay, now we are done with the slicing, and I also want to talk about the preparation quickly. Preparation means that you prepare not just a slicer profile, you also have your printer ready, and you have it ready in a state where you don't have to level the bed or something when the print race actually starts. I often see comments in the chat, oh, my printer is not ready, I can't participate today. So maybe think about it a few hours before, and yeah, then this will not be the problem for you. And of course, the slicer can also be opened before the print race starts, and you can load the filament before the print race starts, and you can preheat the print bed before the print race starts, but don't preheat the hot end to the full printing temperature and let the heat clear up. That's not a good thing. It could clog your hot end, and isn't worth the time saved here. And yeah, then when it goes to the end of your print, make sure you have a camera ready. Don't search your phone after the print finished to take a photo of it. And also think about where you're going to place the model, because as you know, the build plate photos are not allowed. So make a nice place to put the model in, and have your camera ready. This is also something maybe to save you a few seconds. And yeah, if everything worked out, then congratulations on your Polymaker spool that you just won in the print race. And don't forget to upload your models on Printables. And in the next step, I'm going to show you the actual slicer settings and how to slice a few models.
That had a lot of awesome information in it, didn't it? Okay, the next segment that Sebastian goes into is how to create a slicing profile. And then after that, he'll go through a sample slice. Let's continue.
Okay, let's take a look at the slicer. I'm going to use a standard or pre-configured Ender 3 profile for the standard Ender 3, in this case with the BL Touch. I'm going to use Prusa Slicer just because I'm more familiar with Super Slicer and it, but you could also use any other slicer that you want, and the name of the settings is usually quite similar. So let's start with this one. I'm starting with the vanilla pre-configured profile. The feed rates are high enough, I would say. So yeah, maybe we can increase the extruder feed rate a bit, but here we have to really do the modification. We need much more acceleration. We do this in the X and Y direction, not in the Z direction, and the extruder acceleration maybe a bit higher. But these are important as well. While retracting and while extruding, we also want to move fast. Looking at the jerk limits would now be a bit complicated. If you're running Clipper, this is the square corner velocity, and you say that in Clipper anyway. Okay, this is just the maximum the slicer would allow. We have to set the actual speeds in the printers, in the print settings later. And here for the extruder, also some important settings. If we are using variable layer height, this will be the smallest and the biggest layer height it will set here. So we increase it a bit, I don't know, maybe 0.12 and maybe 0.34. Retractions, this is a Bowden setup. Yeah, let's just pretend we have a direct extruder put on the ender. So it gets a bit faster. Next filament, yeah, we need a bit more temperature here. But yeah, 60 degree, 50 degree, or whatever works for you. And the really important thing is here the cooling. This can't stay the way it is. We reduced that drastically here, and also we are looking for the flow rate limit. Here is the flow rate limit under advanced. It's in another place with Super Slicer. And just assume we are going to run a Volcano Hotend or something like that, which can extrude at 25 millimeter cubed per second without a problem. So let's set this. You have to calibrate this, of course. I can't tell you the value you have to set there. Just extrude and extrude and extrude at higher flow rates, and look what the hot end and the extruder can handle before the extruder skips and enters here. Okay, so we should be fine with the filament settings. Maybe we can also just save it here right away. Print trace. Print trace. You should make separate profiles, of course, for your ordinary printing and the print trace, because you don't want to use 1 second layer time for nice prints. Okay, so the print settings, which have most of the general slicing parameters for the model, we have to start modifying something here. I'm going to go with 0.24 millimeters here as default. I have my printers calibrated for the first layer for 0.28, usually easier to do than the 0.2. And now we have to reduce the material that we are extruding, so parameters 1. Don't set the spiral waste mode here. You can activate it if you need it. Top layers, also just 1. If you need more, we're using the modifiers here, so modifiers and not default settings, because these can take up so much time, I tell you. Bottom layers, you could justify 1 or 2. I say we're going with 2, because if we select just 1 and the print doesn't have a good base there, that's something that could cause it to fail. So we are going to be on the safe side with 2 here. Okay, it's not much, of course. It's not great for a functional model, but we want to print fast. So, okay. Yeah, these are not things we want to change in this case. And seam position nearest is best. Yes. Fill gaps. No, we don't fill gaps here. And this is also too much. We want way less infill, and we want the fastest infill patterns, and this is something we can leave the way it is. Ironing, no. Combine infill every 2 layers. No. Only infill where needed is an option, but I usually don't like it. It's something I would do as a modifier manually if it makes sense, or just disable the infill and then edit where I need it. And this is something we don't need. Yeah. The skirt. Do we need a skirt? Okay, we're doing 1 layer of the skirt, and a height of 1 is fine, not 2. Supports are turned off, of course. If we need supports, we use the paint on supports. And now the important part, speed parameters. 200, small parameters. 150. I'm assuming we're using a bed slinger with clipper now or something like that. External parameters are, we can make a nice print here. We go with 150 as well. Infill 200. Solid infill 200. Top solid infill, maybe we are a bit more cautious here with 120. Support material 200. Bridges are the only thing we have to be careful, because these could fall down, and if they don't adhere to the print, then the print fails. So we're conservative here with 90. Gap filling, we fill the gaps quickly. Now travel 250. And the first layer speed, of course, we can go much faster. We can go with 80 or something, but depends a bit on your print bed. And here the actual acceleration, this G-code set acceleration, it would override your printer configs. So yeah, let's go with 4000, 2000 here. 4000 for the default, so it sets all the accelerations here to 4000. For a bed slinger with clipper, I think it's okay, and the bridge acceleration may be a bit lower. We don't have so many bridges anyway. Okay, multiple extruders, we don't have that, so I don't use it. And here the extrusion width 0.44, that's about 10% more than the nozzle diameter is okay. If you have something here that's way bigger than the nozzle diameter, turn it down. I guess these are also okay. These are the default settings just for the pre-configured profile, so someone put some thought in it and we don't need to change that. Okay, then let's also save this. Let's call it print trace. So okay, now we have a slicer profile and we need to add some models. Okay, now I have a model from a previous print race here. I will just pretend the print race just started and we just pulled it in. The first thing is we are going to look at it, and yeah, one thing we notice is that this would need supports. We don't want to print supports, so this is something I would cut. It's only one part, but it needs to go on several printers anyway. So let's go to the bottom of the sword here and cut it just above the rock. So fine, we're keeping both parts, of course. We need to print the sword as well. Okay. So don't delete anything here, just hide it, and if you hide it, it won't slice. It will just slice the rock now when you hide it here. Now to the rock. Next thing to consider is this a waste mode print? I would probably say no, because we can't print the top layer here very well in waste mode, so it's not a waste mode print. Then the next thing we are going to do is to check if we want to use variable layer height, and yes, it is a good print for variable layer height, so let's do the adaptive layer height. We don't really need so much green here. Let's make that a bit faster to default layer height, but we can print quite fast here. That's just upwards, and yeah, should print fine. Okay, then we have that. And what else to consider? I think it's something with a flat top surface. So we have to check for the modifiers now. It doesn't need supports, obviously, but the top surface won't print well this way. So let's go back to the normal view here and add a modifier, a box. Okay, so too small box, and make it a bigger box. So now we have the box, and we want to use the box to increase the number of top layers here, because we don't want the top layers all the way around on the overhangs here. We want it on the top only where we had a hole if we didn't add it. Generic box, and for the box we can now add modifiers like layers and perimeters, and here we have the solid top layers. Okay, start slicing, and let's see how it turns out. Of course, we don't need supports here or anything else. And now we have the first slice. First layers look okay, then we can print up without a problem, and the top also looks fine. Yeah, the amount of infill. Do we actually spend a lot of time on infill? Yes, we do. How can we improve that? Maybe we are going to add another modifier and just do infill in the middle. Remember, we are saving 8 minutes of infill here, so give it a bit of time to slice it here. Add another box. We want a modifier, not a part. Here, box. Make the box bigger. Move it around. And we need a bit of infill below the top layer. It needs to bridge here around and then stabilize, and this should be fine by the way by the time it arrives at the top. So okay, generic box, and here we're going to modify the infill and set it to 0. Oh, and we're down to 14 minutes, and from 8 minutes of infill we are down to 21 seconds of infill. That's much better. So at this point I would take a final look at it. Good enough, I would say. Yeah, bit fragile, but I printed it this way, I think, and it worked, and so we can try it. And now I would double check, is the right profile selected here. For this printer I want to print it on, not for other one. And yes, it is. And at this point I would just export the G-code. Or if you're running Octoprint or if you're running Clipper, you would send it to the printer now, and from this moment on, if the bed is preheated, maybe 1 minute to preheat the hot end, and then 15 minutes later this is done. So we have 15 minutes now. I just sent it in virtually. So I have 15 minutes for the sword here. Okay, just going to move this away. No, not the box. I want to move the whole thing away. Here. If it lets me. Yep. Yeah. So good enough. Do we want to print it this way? No, we don't, because it requires supports. We are going to lay it flat. Place it on flat surface. No, this is not so good. Rotating it manually then. Okay, is this printable? I guess so. Good enough. Now we have to consider, no, we do not split it. Yes, we do want variable layer height here, because it would look very rusty on the top. Adaptive, oh, this is actually very thin with the layers here. How long would it take? 8 minutes. Okay, it's fine. If we have a printer that is also that fast and can print in 8 minutes, we can say we print a higher quality sword, maybe do a few thicker layers in the middle, but leave the top layers like this. So okay. Then just make sure again. I don't think anything can fail here. It's really a flat object, so not much to fail here. So we could slice it. Check it if it needs a prim. Doesn't have enough support here. There's no first layer here. Okay. No, prim is not good. Maybe I paint on a support here. Just a bit. Should be good enough here. Yeah, we need to enable them Yeah, this would print fine, I guess. Prints up here and bridges over there, I guess. Yeah, why not? Can we support the whole thing? I mean, the other thing is printing now virtually, so we can check if we have time for that. 8 minutes. Okay, it should print well now. Okay. Yeah. So we are having two parts here. I would just check if the profiles are the appropriate ones and send this to another printer. Or even if I just had one printer, I would print this after the one part because it's better if we lay it down flat, because we have too many short layout times printing it upright, and this would be a cooling issue. Okay, I would send this to the printer now and print it. And in the meantime, because we have two parts, you can either search for your glue bottle, or because I didn't have any glue yet, I took out the hot glue gun and heated it up. And this other part only, where is it? Only takes 15 minutes, so we don't have too much time now. And remember, no, both parts are printing, and now you can prepare the photo, and you can prepare what you need to put it together. And yeah, hopefully no one is faster than you are. Okay, maybe also something that I should show you is not just the speed, but because we talked so much about cooling and layer times, if we slice this properly, we have a decent flow rate here. And you see orange is about 20 millimeters cubed per second. And of course, we are going to slow down a bit for the thinner layers that we set in the variable layer height in terms of flow rate, but most of it is around just under 20 millimeters cubed per second, which is probably good enough for the flow rate. If it was around 10, I would think that it's not enough and we can go faster. But yeah, we don't need to use all of the flow rate, because we get in this region where the Hotend isn't linear anymore. If you say it's the maximum 25 millimeters cubed per second Hotend, and we only have one parameter here anyway, so this is what I consider good enough here. And the layer times, we just want to make sure that this is not slowing down too much because of the cooling, and it does not. It's 2 seconds everywhere. And yeah, if it would go considerably up in layer time here, we would have to adjust cooling as well, but this is fine.
Pretty awesome, wasn't that? That's like information overload when it comes to slicing and 3D printing. Thank you, Sebastian, for taking the time to put all this information together. Thank you. I know that's a lot of work to put together a presentation, and we're grateful for it. I hope all of you that were watching, I hope that you learned something, and we invite you to come by the LM show on Fridays. Well, actually Monday, Wednesday, or Friday. Be there for all 3 shows. But on Fridays at 5 p.m. Pacific, we have our print races, and we'd love you to come by, participate. We award prizes not just for speed, but for creativity, for picture and video taking. And it's just a really good time. Come by, hang out, twitch.tv/loyalmoses at 5 p.m. Pacific, Mondays, Wednesdays, and Fridays.